When it comes to our next option, it's a case of weighing the potential benefits against the possible detrimental impact. Dispersants, when used appropriately, can help reduce the impact on seabirds, mammals and sensitive shorelines. But it's important to be mindful of how it may affect the marine environment. Dispersants reduce the amount of wave energy needed to break the oil slick up into lots of small droplets. They're sprayed from vessels or aircraft. The dispersant molecules align at the interface between the oil and the seawater, and the micron-sized droplets formed as a result are then diluted by the sea's natural mixing energy and degraded over time by microorganisms.
Dispersants can be sprayed from a variety of different platforms. It can be a seagoing vessel, or indeed you can spray from the air, from a rotary wing helicopter or from a fixed wing plane. Each of them have different advantages, they have different payloads, but basically when you're applying dispersant you can treat large slick areas in quite a quick time frame. So, I mean, spraying dispersant has many advantages.
To get to grips with some of the issues, I've come to Pembrokeshire in South Wales, scene of both a serious oil spill and also one of the most effective uses of dispersants. In February 1996, the oil tanker Sea Empress grounded just over there on the far side of the bay. She spilled 72,000 tonnes of 40s blend crude oil into the sea. A major focus of the response was to spray 445 tonnes of dispersant, mostly from aircraft. First focusing on the freshest part of the spill before moving attention to the larger, more weathered patches. So was this approach a success? To answer that, I've enlisted the help of Dr. Tim Linnell from Itopf. Tim, you were here during the Sea Empress incident. Where were you and what were you doing?
Well, back in February 1996, day not very dissimilar to this one in fact, we were out there behind where the DC-3 aircraft were spraying dispersant onto the oil that was being, the freshly released oil that was coming out of the Sea Empress.
Wow, so you're actually on the water as the aircraft come over.
Absolutely.
Is that a bit dicey?
Well, it might sound that way, but we were sort of well-practiced teams. We were used to working together. And also, I mean, the dispersants themselves, these modern ones, are formulated specifically to be very, very safe. They're safer than the detergents that you've got as washing up liquid on your kitchen sink. So really in terms of that side of it, we didn't have to worry about the dispersants. What we had to really think about was the toxicity of the oil, both for us but also for the marine environment.
From being out there on the water, what did you observe?
Well, it was interesting. When the dispersant was sprayed on top of the water and oil emulsion that was forming, there wasn't any immediate sort of dramatic effect. But because we were out there, we could follow that over the next 3, 4, 5 minutes, look at the wave action working with the oil dispersant mixture. We could see the emulsion started to break down, and then after about 3 or 4 minutes, you got that very characteristic sort of coffee-coloured plume that you look for.
The team continued to apply dispersant for 7 days and carefully observed the effects. So what did you conclude?
Well, by being out there and sort of using the different monitoring techniques, we were able to see that the 445 tonnes of dispersant that was used was able to remove somewhere between 18 and 27,000 tonnes of oil from the sea surface and disperse it into the water column.
So even if you take the lower figure there, that means that each tonne of dispersant treated 40 tonnes of oil. This success story is partly down to the type of oil spilled, 40s blend being particularly dispersible, but also the oil spilling over a period of 6 days gave the responders a technical advantage.
With these sort of well-practiced and targeted teams, we could really focus on those patches of fresh oil to make sure the operation was as effective as possible. And really what that meant was that the 18 to 27,000 tonnes of oil could have formed a water and oil emulsion, and that would have increased its volume by 3 or 4 times. So we could have been sort of looking at 60 to 100,000 tonnes of oil coming ashore.
So it sounds like it was the ideal use of dispersant right here.
It definitely reduced the environmental impact of this particular spill because of the combination of circumstances that we had.
It's worth remembering though that the oil hasn't disappeared, it's now in the water column, and we need to think about how it might affect sensitive areas such as fish spawning grounds or aquaculture.
The Dispersed oil from the sea empress was particularly affecting the shallow populations of bivalves, the clams like cockles and other shells that are living in the sediments. They seem to eject themselves from the sediment and were getting washed up on the shoreline in very large numbers. The effects on other marine life in the waters were largely indetectable. Most species and habitats around Pembrokeshire within 5 years, mostly within 2 years, were back to typical normal levels.
But despite this success, it's worth remembering that the use of dispersants is not universally accepted. In many countries, their use is restricted or banned. When they are used, even where they reduce the volume of oil reaching the shoreline, they can generate some negative publicity. It's important to recognise it's a trade-off.
In the case of the sea empress, the sort of use of dispersant undoubtedly resulted in a net environmental benefit. But that won't always be the case. So if, for example, out there we had a coral reef, in that case, taking the oil from the surface and putting it into the water column wouldn't necessarily provide a net environmental benefit. Particularly if, as now, we've got this hard sand beach where the oil can be left on the sea surface, can come ashore and can be removed. In that case, you probably would not want to disperse it. If, on the other hand, here we were standing in a mangrove, then actually the oil would come potentially into the mangrove area and become trapped. And therefore, even in that case, even though you might still have a coral reef out there, you might want to disperse the oil because you'd reduce the chronic pollution you might otherwise get from oil being trapped within the mangrove and then being released over time. And so that's why it's really important in these sensitive environments to have experts such as those at Itopf that can really understand the kind of sensitivity to oil pollution that each individual environment might have, and importantly to understand the response techniques that can work with those natural processes to sort of reduce that long-term environmental impact.
Making the decision to use dispersants is rarely easy, but time is an important factor, so contingency planning is crucial. And when planning, there are a few key things to remember. First, there's a narrow window of opportunity. Depending on the oil's properties and the conditions, that could be a few days or a few hours, because once the oil is weathered, dispersants are less effective. Second, oil type is crucial. While light oils readily disperse, some viscous crudes and heavy fuel oils don't. And finally, the sea state is a factor. If the sea's calm, the droplets will float back up to the surface to form a slick. But if it's too rough and there's lots of wind, it can be tough to apply the dispersant effectively.